Automotive, electrical and four-wheel drive accessories. A4A, that's us. G'day campers, my name is Greg Lukey and today we're very proud to show you a brand new product, the KT Power Meter. Power meters, what are they? You've probably seen a lot of them around in the industry. Normally they've got two short flying leads and two high-powered 50 amp connectors. That means when you bring the other two connectors up to the power meter, you end up with four connectors. What we've done at KT, we've innovated a one-piece moulded housing, which already has the connector housing in it. So what you do is you just bring two connectors up, not four. It's short, it's smart, it's a white piano finish, it has a very bright LCD screen. So what do power meters actually do? Power meters show you voltage from the battery, either supply or source. They show you the running amperage of an accessory drawing current, and then when the two are multiplied out, you get wattage, the actual working power of a device, like this fridge. Power meters are actually what they call bi-directional. That means there's a supply and there's a source. Here we have a 100 watt solar panel connected to the power meter through the MC4 connectors to a 50 amp connector straight in. Alright, I power up the meter and we have what we call a VOC, voltage open circuit. We've got a bit of shade right now, so it's showing 19.6. When I get a bit more solar irradiance, a bit more solar harvest, that should come up to about 22 volts. What a great way to check if a solar panel is working right in front of your consumer. Here we go, we'll power up the meter. We've got 12.6 volts. We've got an amp draw of 5.3. Now that's because the fridge was off overnight, we've just powered it up. So there's a spike there in current. National Luna, as you know, is famous for low current. So once this reaches an equilibrium temperature where we've set about -4 or 0 degrees, that amperage will drop down to that particularly famous 2.3 up to 3 amps. When you multiply the amps times the voltage, you get 66.8. That's actually the working power of this fridge right now with the compressor running under load. Now remember, whatever comes out of the battery bank, you've got to put back. So we don't have a solar panel connected to this battery, but if we did, the money coming out of the bank would be replaced by the solar power natural harvest, or what we call irradiance. So let's look at the other direction. If the battery is the source and the fridge is the load, that's easy. We've got the voltage of the battery while it's going to the fridge. We've got the amp draw of the fridge. The two are multiplied out inside the power meter to give you the working power wattage. Let's take away the battery from the source and we connect the solar to the source because the natural harvest of the sun is supplying the energy. So the solar panel can come through the source and the other side can be the battery. As you can see, the battery will be connected on both sides of a power meter. That's why we call it bi-directional. Supply and demand. Simple as that. What's being demanded is being supplied, either from a battery or the natural harvest of the sun. The power meter has two easy little mount screws here, so it can be flush mounted against a flat panel. It can be mounted vertically, any way you like. Also a great tool in the workshop. You can have it in your hand and just plug it into any 50 amp connector to get the live voltage of a battery, be it auxiliary or main, whatever the car's wired to. The only place it can't go is under the bonnet, where there's heat and there's a lot of water generation and what we call road moisture. But the power meter is a very, very, very handy little tool, either in the back of a four-wheel drive or in the workshop. It has an LCD screen that stays lit for 15 seconds. That's a power saving feature. And when the screen goes out, you just touch it and it comes back on. The KT Power Meter, a necessity in every four-wheel drive and camping application. Thank you for watching.